Okay, let us discuss this problem. Once again taken from Irodov. This is 1.120. So we will discuss problem number 1.120. So this is 1.120. So let me make. Now see what this problem says. The kinetic energy of a particle along a circle, moving along a circle. So I have a particle that is basically moving along a circle. So I have a circle. Particle is moving along a circle. So let us say point A, particle is here, and kinetic energy is given by a s square, where a is a constant and s is the distance covered by the particle, and radius of circle is also given r. So radius of circle is r. A is a constant. What about s? So we said s is the distance traveled by the particle. This means this is the distance. So along the circumference, this is the distance. So this distance is covered by the particle. So you can understand now what I mean if I say distance. So let us see here. Now next part. So question asks, find the force acting on the particle as a function of s. So what we have to find it out? So we have to find it out, force acting on particle acting as a function of s. So this means to move this particle in circle, I have to change the forces. This means a different s, I will have different force. So let us use the idea. Anything moving in a circle, if anything is moving in a circle, it will have a radial acceleration, it will have a tangential acceleration. Tangential acceleration is given by dv by dt, and if you remember, radial acceleration is given by, what is this? V square by r. Now if you know the radial acceleration and tangential acceleration, you can find radial forces and tangential forces. That is, radial forces is equals to mass into acceleration in the, so this is the tangential, in the tangential direction. You can find radial forces, that is equals to mass into acceleration in radial direction. And then what you will do, the net force will be a square root of, so F net will be a square root of Fr square plus Ft square. Now we will work on the same background. So let us say half mv square, that is kinetic energy, is given by, in the question it says it varies with as square. So you see here, so this is as square. Now so I can find mv square is nothing but as square. So mv square by r is nothing but a square by r. So this is mv square by r is the force. So force along the radial direction is what you see here, m into acceleration in the radial direction, that is v square by r. So this is v square by r. So this means mv square by r. This is simply nothing but force along the radial direction. Now let us find, I have to find tangential direction force. So I have to find dv by dt. Now I know this v square is given by s. So v is kinetic energy, half mv square is given by as square. So you see, it's given in the problem, kinetic energy varies with as square. Now if I take this side, so this becomes v square is equals to 2as square by m. Now if I differentiate this equation, so this becomes 2ab, and differentiation of v is nothing but dv by dt. So you keep writing. Let me wait 1 minute, so that if you have left anything, you just write it up, and then we'll go further. So this is, differentiation will be, v square will be 2, so simply 2v, not a. So 2v dv by dt. So differentiation of v square is 2v dv by dt, not a, into 2a by m, and if differentiation of s square is 2s, and then I will also have, because s is varying with time, so ds by dt. Now you see, if I eliminate 2, so we will have v dv by dt, and there we have 4, 2 cancels out, so we'll have only 2, and I will have as by m ds by dt. Now if you see, ds by dt is what? ds by dt is nothing but tangential, so you see velocity, so ds by dt. So what is the rate by which s is changing? And s is changing, so this means at any point of time ds by dt is nothing but equals to v, tangential velocity. Are you getting or not? Because ds by dt will tell you what is the rate by which s is changing. S is the circumference area, so this is the tangential velocity. So I can also write ds by dt is nothing but v. If I write ds by dt is equals to v, so I can cancel these two terms. So this becomes dv by dt. If I take m this side, so this becomes simple 2as. So my m dv by dt is nothing but radial tangential direction force. You see here. So ft is m into at. At is nothing but dv by dt. So ft is m dv by dt. So this becomes ft is m dv by dt, that is 2as. I am getting from here. So now I have radial velocity as well as the radial force as well as, so this is my tangential force. I have already calculated the radial force. If I square root, take a square and take root of both the terms, I will have net force, that is 2as whole square, plus here I will have as square by r, that is as square by r whole square under root. So this will be the net force. Now if I take common a and s also I can take common. If I take as common, so I will have basically as is common, so I will have 4s square here. As is gone, so simply I will have 4 plus no s, so there is no s, plus, because s is common, as is gone, so I will have simply 1s and s square by r square. So this we will have s square by r square. If you have confusion, let us rub this one. There is nothing. Now if you go further, one more line, I can also write, if I take r common, so as by r, so this will become 4r square s square. Are you getting or not? So let me see the answer, whether this is the answer or not. So question number 1 point, you can also see your answer, 1.120 if you have the book. So this is 2as. Where is my 2? Okay, so 2 I have to take common it out, and then we will get the 2as 1 plus s by r whole square. So I think somewhere I have missed 1 2. Whether I have missed 1 2, let us check this 1 2. So this is I have missed it here. You see, mb square by r is nothing but, so I have to multiply this 2 here. You see, half mb square is as square, so mb square is equals to 2as square. So I have missed 1s. So this is my basically fr is, I have to 2 here, I have to add 1 2, and then this becomes 4. So now I can take 4s common, so 4 common, and so this becomes 2as. In answer r is inside, so even if I divide by r, so this becomes 1, so 2 common and divided by r, and this will be s square by r square. Are you getting or not? You just do your calculation, you will get the answer. So in this problem what we have, important point is, so we have used the idea of circular motion, that in circular motion we need two kind of forces. In tangential direction I need one force, in radial direction I need one force. In tangential direction force is mass into dv by dt, radial direction force is mb square by r. B square is given, that the problem says kinetic energy is as square, ax square or as square. Now kinetic energy is given, I can directly find v square, and from v square I can find out the radial force. If I differentiate the kinetic energy, I will find dv by dt, and that dv by dt, if I incorporate in m dv by dt, that will give me my tangential force. So correspondingly we can find radial direction force as well as tangential direction force. We'll discuss the next problem.